Good morning, students. Chapter 6, Work, Energy and Power, a new chapter. Yes, we use these words in daily life. What is work, energy and power? Okay, yes, if you are reading, then yes, you say to your parents, yes, I'm working. Okay, I have to do some work. I have to do some work. Okay, and thus, yes, for doing that work, you say, I'm using my energy. I'm using my energy. Okay, and yes, we also use these three words in regular life. What is work, energy and power? Okay, right now I am taking lecture. So yes, you may, or you can say, yes, sir is doing some work. You have to watch videos. Yes, you can say, yes, I am watching videos. Means I have to do work. I have to watch videos. But see, in physics, definition of work is different. In physics, definition of work is different. In physics, watching video is not considered as work. In physics, if I am reading something, then it is not considered as work. So, what is definition of work? Energy. Yes, what is energy? Capacity to do work is called energy. Capacity to do work is called energy. But there are types of energy. Okay, what is potential energy? What is kinetic energy? What is mechanical energy? And yes, the most important thing, what is law of conservation of energy? Yes, you know law of conservation of energy. The energy, it always remains constant. Okay, yes. So what is energy? And power? Yes, why power is one important quantity? Why power is one important quantity? Okay, yes, if we apply or if we punch anybody, okay, then yes, that punch, it depends on force, in which time the force is acting, Also, if we do any work, then that work is done in during which time. So that is important of power. Yes, in this chapter we will discuss in detail about work, energy and power. We will start from first definition, that is work. Okay, what is work? Okay, yes, again, in physics, definition of work is different. Okay, if in daily life we are doing some household works, then they are not considered work in physics. Okay, reading, then yes, watching movies. Okay, then if I am doing something, then yes, these things, they are not considered as work. What is actual definition of work? See, work is done. Work is said to be done if due to some external force object is displaced. Work is done when due to force object is displaced. Okay, so here I am taking one situation. See, here it is. If it is one surface, on this surface one block is placed. If on this block a horizontal force F is applied like this, and due to this force, if this block is displaced, by distance d. Okay, here if I have a block, I am applying force F in horizontal direction, and in the direction of a force, if block is displaced by distance d, then on this block work is said to be done. Clear about this? Okay, so yes, again, if I have one object, force is applied, and due to that force, if object is displaced, then work is said to be done. Here, remember one important thing. Force is applied in horizontal direction. Block is also displaced in horizontal direction. So here as shown in figure, force applied in horizontal direction. in horizontal direction, in horizontal direction. Okay, block is displaced, block is displaced in direction of force, in direction of force. Okay, so therefore work is done on block. And how to find that work? What is definition of work? Okay, work is equal to it is force into displacement. Work is equal to it is force into displacement. So here I can write work as W is equal to force into displacement. W, work is equal to it is force into displacement. Clear about this? Okay, so yes, in this case one, I have this situation. On block, force F is applied, and due to that force, block is moving in direction of force. So yes, work W is equal to Ft. Now, it is not necessary always that this force is applied and displacement is in direction of force. For example, if I have one block like this, okay, force is applied in this direction. Force is applied in this direction. Okay, and due to this force, object is displaced in this direction. Object is displaced in this direction by distance d. By distance d. Clear about this? If it is one block, force is applied in this direction, okay, and object is displaced in this direction, then how to find work? See, here you have to take component of force in direction of displacement. You have to take component of force in direction of displacement. Here displacement is in horizontal direction. So let it is horizontal direction. Let this force makes angle theta with horizontal direction. So see here, as shown in figure, force F is applied at angle theta with horizontal, okay, but block is displaced in horizontal direction. Block is displaced in horizontal direction. So in such case, to find work, consider in this case, to find work, consider component of force in direction of displacement. Yes, here I have assumed this angle theta. So if I resolve this F in two components, I will have two components. One component in this direction, another component in this direction. So yes, this F is resolved in two components. One, this component becomes F cos theta, and this component becomes F sin theta. Clear about this? So yes, this F is resolved in two components, one F cos theta and one F sin theta. So here in this case, how to calculate work? So here, work done, W or work done is equal to, how to find work done? It is component of force in direction of displacement into displacement. Okay, so in this case, if I want to write what is equation of work, then yes, what is equation of work? So in this case, how to write equation of work? It is like this. It is like this. See. Okay, in this case, how to write equation of work? Then see, W is equal to, here it is, W is equal to component of force in direction of displacement, means F cos theta, means F cos theta. And what is displacement? Yes, displacement is D. Displacement is, clear about this? Then how to write equation of work? W is equal to, it is FD cos theta. W is equal to, it is FD cos theta. Clear about this? Clear about this? So yes, here see, W is equal to, it is F D cos theta. F force, vector quantity. D displacement, vector quantity. Theta, angle between F and D. Theta is angle between F and D. So yes, yes, yes. And this work is scalar quantity. This work is scalar quantity. So yes, this force and displacement, if they are vector quantity and the resultant is scalar quantity, then what is relation between them? Yes, I can write W is equal to, it is F dot D. There is dot product between these two quantities. There is dot product between these two quantities. And now from this we can write what is definition of force. See, in first case, force and displacement, they both are in same direction. In second case, this force and displacement, they are not in same direction. So what we have to consider? Component of force in direction of displacement. So what is definition of work? Okay, a work is defined as product of component of force in direction of displacement and displacement. Clear about this? Okay, like this. See, component of force in direction of displacement into displacement. Clear about this? So yes, work W is equal to, it is F dot D. Work is equal to, here it is F dot D. But see, this theory is about, this equation is for constant force. This equation is for constant force. W is equal to F dot D is for constant force. Is for constant force. What is meaning of constant force? What is meaning of constant force? If you are applying 10 Newton force on this block at time t is equal to 0, then at time t is equal to 1, at time t is equal to 2, 3, 4, 5, force value remains same, that is 10 Newton. Yes or no? So what is first case? This first case is about work done. This first case is about work done by constant force. This first case is about work done by constant force. Here this force F is constant. Here this force F is constant. Okay, work done by constant force. So title of this theory is work done by constant force. Clear about this? Okay, where F is constant, throughout the process, F remains constant. Throughout the process, F remains constant. Clear about this? So yes, it is equation of work. W is equal to F dot D. Force, vector quantity, displacement, vector quantity. Now what is unit of work? See, here it is. See, here it is. Work is equal to force into displacement. So it's unit of work. Unit of work. W is equal to force into displacement. So what is unit of force? Newton. What is unit of displacement? Meter. Is Newton into meter. And it is also called joule. So 1 Newton meter is equal to joule. If 1 Newton force displaces object by 1 meter, then it is said to be 1 joule work. Then it is said to be 1 joule work. Okay. Now see, there is one important result. In this case, force and displacement, they are not in same direction. Yes or no? But angle between them is theta. But if I take angle between them, theta is 0. Theta as 0, then put here cos 0. Then cos 0 is 1. Then you will get W is equal to FD. That is first case. That is first case. Clear about this? Okay. So yes, what is work? What is work? Work means when due to force, object is displaced, then work is said to be done. If due to force there is no displacement, then work is 0. Clear about this? And what is title of this theory? Work done by constant force. Work done by constant force. Okay, we will continue this theory. Yes, we have obtained one equation for work done by constant force. Work done by constant force. That is W is equal to F dot D, or W is equal to Fd cos theta. Now we will think about when work becomes 0, when work is positive and work is negative. So see, first of all, this work depends on angle between force and displacement. This work depends on angle between force and displacement. First case 1, when theta is greater than 90, means first quadrant, and we know that in first quadrant cos theta its value is positive. So obviously work done is also positive. Clear about this? Okay. Second case, when theta is less than 90, that is first quadrant. Okay. When theta is greater than 90, here again, when theta is less than 90, that is first quadrant, cos theta is positive. Okay, and work is also positive. When theta is greater than 90, that is second quadrant, cos theta, we know that it is negative. So yes, work done is also negative. Clear about this? Yes, third case, when theta is equal to 90. So yes, cos 90, we know that value of cos 90 is 0. So cos theta is equal to 0. So work done is also 0. Clear about this? Okay. For example, it is one block. On this block, force is applied in this direction, and block is displaced also in this direction. Then in this case, what is work? Yes, then W is equal to Fd cos 0, means here it is F, that is cos. Okay. In second case, here this block, okay, if we apply brake, then due to brake, frictional forces produced in this direction, but vehicle is moving in this direction, is displaced in this direction. Yes or no? If you remember stopping distance, topic of stopping distance. Okay. So yes, when you apply brake, frictional forces acting in this direction, but object is displaced in forward direction. So in this case, what is angle between them? Theta is equal to 180 degree. Here theta is equal to 0. So what is work in this case? W is equal to Fd cos 180. And we know that what is value of cos 180? -1. So here it is minus. So here work done by friction force, or any opposing force, or any resistive force is negative. Clear about this? So yes, you have to remember this point. Another one, is there always work due to some force? No, it is not necessary. Okay. For example, it is wall. And I am exerting greater force, but this wall is not displaced. this wall is not displaced, it means force acting on wall is 0. So yes, when F is large, but D is 0, means displacement is 0. In this case, work is also 0. In this case, work is also 0. Clear about this? So yes, remember about this point. Okay, force. It is not necessary that every force will produce some work. Okay, so yes, when force is large, D is 0, W is equal to 0. Okay, again, if we apply force, an object is displaced, then again it is not necessary that work done by that force is 0. See, for example, it is blocked. On this block, we know that mg is acting in downward direction. I am applying external force in this direction. And yes, this block is displaced in this direction. So here, in this case, work is done due to this force, not by mg. You understand? Okay, here displacement is in direction of force, not in direction of mg. Is there any deflection of any displacement of object in vertical direction? No. So here work done by mg. Here work done by mg is 0. Here work done by mg is 0. Clear about this? Here again I will take another one example. If it is one clock, force F is applied like this, and object is displaced in this direction, then is this force responsible for this displacement? No. Why not? Because we have to resolve this force in two components. It is F cos theta and it is F sin theta. Here work is done. By F cos theta. Work done by F sin theta is 0. Work done by F sin theta is 0. Why? F cos theta is in horizontal direction and object is displaced in horizontal direction. Yes, force, and in that direction displacement. Force F sin theta is acting in vertical plane, and is there any motion, is there any displacement in vertical plane? No. So due to this force, work is 0. Clear about this? So yes, work, it is one of the important topic. It is one of the important quantity. Okay, what is work? When work is said to be done. Clear about this? Yes, whenever you have to find work, you have to consider component of force in direction of displacement. Yes, students, it is all about our first theory, that is work done by constant force. In each and every case, during motion, force remains same. So it is first equation of this chapter, that is W is equal to F dot D, W is equal to F D cos theta. F force, D displacement, and theta is angle between force and displacement. Okay, yes, it is important chapter in mechanics. So yes, watch regular videos and make your notes, and if you have any doubt then contact teachers. Okay.